So to evaluate this integral, we can go term by term, which is a property of an integral operator. And what you're doing is you're just finding the antiderivative. So I need to think of something whose derivative would be 6x to the fourth. Well, I know that when I take a derivative, the power goes down by 1. So if I take an antiderivative, the power must go up by 1. Okay, but this doesn't quite work because if you were to take a derivative right now, the 5 would come down and multiply to 6 to make 30. 30x to the fourth, not 6x to the fourth. So I can finish my antiderivative by dividing it by 5. So that is the antiderivative of 6x to the fourth. And now we can go to this term. I know my power has to go up when I take an antiderivative, which means I also have to divide this by 4 so that when the derivative happens, we get x to the third, not 4x to the third. And same thing here, I know the power has to go up. And then we also need to compensate for when you take a derivative. The 2 would come down and multiply and mess that up and make it a 6x, not 3x. And then something whose derivative would just be minus 5, that's 5x. The derivative of minus 5x is minus 5. So that's our antiderivative, but think about it. If you could do a plus 1, and that's still the antiderivative, right? Because if you take a derivative of each term, the derivative of plus 1 is 0. How about plus 2? That is still the antiderivative. How about plus 222? Still the antiderivative. So what we do in calculus is we say plus some constant c. It can be an infinite amount of different constants that can go there, but as long as it doesn't have an x, it doesn't mess up the antiderivative. So this is our answer.